Alright guys, this is lesson 1.1, task 3. Graph a function whose domain is restricted. The previous task dealt with functions with unrestricted domains. Sometimes a function's domain value are restricted to a smaller set than all values for which the function is defined. The graph of a function f of x equals 1/2 x minus 2 is shown for x greater than or equal to 4. Restricting the domain to all real numbers greater than or equal to 4 changes the range from all real numbers to all non-negative real numbers. While the end behavior as x approaches infinity is not changed, the end behavior as x approaches negative infinity can no longer be described. Alright, so it shows the function here, and so it's going to have the graph is going to be just an arrow going in one direction, and it terminates right here at 0 or at 4, 0. Alright, so this is why it says as x goes to positive infinity, as x approaches positive infinity, so as x goes to the right, your f of x or your y also goes towards positive infinity. Okay, f of x is my y value, it's going up. Alright, so when x equals 4, f of x equals 0. So it only has one value since it terminates at that point. So it just stops there. Alright, so it says use the graph of the function with the given domain restriction to find the corresponding range. Alright, so it says f of x equals x squared minus 2x plus 2 for all x such that x is greater than or equal to 0. Alright, so this is a parabola, but they're going to terminate it. They only want to look at the function when it's greater than or equal to 0. So here's 0. So everything greater than or equal to 0 on the x-axis, that's our domain. Okay? Alright, so now it says what is the range? Well, the range is your y values, so the range is going to be everything greater than the lowest point. So the lowest point of this function, you can see it starts here and comes down and then turns back up at the vertex and goes this way for infinity. But the lowest point is at 1. And since that's a solid line, that means 1 is included in that solution. So your range is f of x such that f of x is greater than or equal to 1. Okay, and again, f of x, that's my y-axis. Okay. Alright, f of x equals 2 to the x power for all x such that x is greater than 1. Okay, so this time it's not greater than or equal to, it's just greater than. And they represent that by having an open circle here. So this graph starts at 1, 2, where 1 is not included in the domain or the range. Okay, so it's not included here for the domain. And when we come down here, we need to make sure that it's not included for the range either. The only difference in the first two is whether that point is included or not. Okay? Oh, sorry, I'm looking at the wrong one. The range is your y value. So the x is 1, that's my domain. The y is 2. 2 is not included. Sorry about that. Alright, so how does the open circle in the graph relate to the range? Okay, so that's what I was trying to explain and got me kind of mixed up. The open circle means that this point is not part of the solution set. It's not included in that graph. So it's not included here for the domain, and it's also not included here for the range. Alright, that's all for task 3. If you have any questions, please let me know. Lesson 1.1, Task 4. Model a real-world situation with a function. Real-world situations often require restrictions on the domain of the functions that model them. Sometimes this is because many real-world measurements, such as time or distance, must be non-negative numbers. For example, the distance that a jogger travels at a constant speed of 6.5 miles per hour can be modeled by the linear function f of x equals 6.5x, where x is the time in hours the jogger runs. The domain is the content is x such that x is greater than or equal to 0. The domain in this context. Getting tongue-tied today. All right, a home remodeling company is creating a kitchen island with a workspace countertop. The length of the countertop is to be 3 feet greater than the width. The width must be at least 20 inches. Okay, so those are probably important things to remember. The length is going to be 3 feet greater than the width, and the width must be at least 20 inches to allow for sufficient workspace. Create and graph a model of the area given these restrictions. Is it possible for the countertop to have an area of 7 square feet? Explain why or why not. All right, so they're giving you an image here. So you've got width going this direction. We know it has to be at least 20 inches. And we've got the length, which has to be at least 3 feet longer than the width. So it says write a function to model the area. Let L represent the length and let W represent the width. The length is 3 greater than the width, so we can write that as length equals the width plus 3. All right, so you know that length times width is going to be your area, and length times width would be W times W plus 3. So it says the area of a rectangle is given by length times width, so an equation for the area of the rectangle is, all right, let's see if I can get my pen to work here. So if we've got W times W plus 3, we can simply distribute that. Okay, so this is our length times our width, and this is considered our length now, and this is our width, so it's going to be W squared plus 3W. All right, so that's going to be W squared plus 3W. All right, so it says what is the domain and the range. All right, remember the domain has to be at least 20 inches. And all right, so this says the length is 3 feet greater than the width. So we have to convert from inches to feet. So how many feet is 20 inches? So if we have 20 inches, and we know that 1 foot equals 12 inches, we know that 12 from 20, so we know we've got 1 foot, and then we have 8 more. 12, or 20 minus 12 is 8, and 8 over 12 is 2/3. So our domain is going to be, our width is going to be W such that W is greater than or equal to 1 2/3. 1 2/3 feet is equivalent to 20 inches. All right, and it says what is the range? Well, we know that the range has to be 3 feet more than, the length has to be 3 feet more than the width. So if this one's 1 2/3, if we add 3 to that, that would be 4 2/3. So let's see. So if we have 1 2/3, so if I change this to an improper fraction, that's going to be 5/3. And if we have to add 3 to this to get our other side, or our length, we're going to have 4 2/3. So multiply that, get 12. So that's 14/3. And so then I'm going to multiply 5/3 and 14/3. So 5 times 14 is 70. 3 times 3 is 9. So this is going to be so our range is also, so this is in feet. So how many feet are we talking about here? So if we have 70 feet, it's going to be 7 and 7/9. All right, so all you have to do is how many times does 7 go into, or how many times does 9 go into 70? And that's 7 times. 7 times 9 is 63, and 70 minus 63 is the 7/9 right here. So all you're doing is working with fractions to figure out what the range is. So the domain is your x value, the range is your y value, and so this says that the range has to be greater than or equal to 7 feet and 7/9 of another foot, so almost 8 feet. All right, so it says, how did you determine the descriptions for the domain and the range? So the problem states that the width must be at least 20 inches. So that tells me that the minimum value for the range is 20 inches, which is equivalent to 1 2/3 feet. The minimum length is supposed to be 3 feet more than the minimum. So that gives you 4 2/3, which is equivalent to 4 2/3 is equivalent to the 14/3. And then if you multiply these two together, you get the 7 and 7/9. All right, so if you graph the function, it's going to look like this. It's going to be your domain and range. That's your endpoint here. Has to be a minimum width of 1 2/3. It has to be a minimum height, or I'm saying height, a minimum length of 7 and 7/9, and that gives you anything greater than or equal to that would be in that direction there. How does the domain and range affect the way the graph of the function looks? Again, it has to be graphed greater than or equal to that because you're talking about distance, a length or a width. All right, so it says the area of the countertop is at least 7 7/9 square feet, which means that it is not possible to create a countertop of 7 feet. So if it has to be 7 7/9 or greater, then you can't have a countertop of 7 feet. All right, so that is all for task 4. If you have any questions, please let me know.